This is for specialist maths. It comes out of the Northern Hemisphere 2017 Spec Exam 2, Question 3, Part B. It's a question that I was working with both Ming and Christine about, and it's about the limiting value of P and how we might find what that limiting value is when my differential equation is dP dt in terms of P. So why might it have a limiting value? If I'm graphing P against T, then P must approach a value and then approach that asymptote. And the asymptotic value, for example, P equals 0.9, would be the limiting value of P. Now, I can't solve this for P. So I need to think about what's actually happening here. And what's actually happening along here is the gradient is approaching 0 because this curve is approaching the asymptote and getting a gradient that is closer and closer and closer and closer to 0. Therefore, at the limiting value of P, the gradient will equal 0. So if I set dP dt equal to 0 and solve for P, that should give me my limiting value. So over here, if I've got x divided by that equals 0, and I get x equaling 0.89425 equals 0.894. Okay, so the idea being that where it's going to be limiting, it's going to approach that particular value, therefore your gradient is going to be approaching 0.